Well, hello, everyone. Thank you for joining us for the next installment of KBE Insider. The point of the show is that we interview people who are actually kind of doing the work in Kubernetes with the hope of finding out what's really going to land over the next, say, 6 months, rather than talking to necessarily product management. Because the challenge with open source, of course, is that people always have the option to work on a night or a weekend to get the feature they really want in, even if a product manager doesn't really want it. So as a result, we find it's more interesting if we talk to the people who are actually kind of, like I said, doing the work. I'm Langdon White. I am a clinical professor at Boston University, and I teach data science at some level of computer science, as well as an experiential learning program called Spark. So if you see my water bottle, you'll see what the logo, name collision on Apache, notwithstanding, it's been around since about 2017. So that's me, and I'm joined by my co-host, who is Josh Berkus, and he's going to introduce himself.
Yes. Hi, I'm Josh Berkus. I've been involved with Kubernetes and the CNCF for as long as both have been around. I work for Red Hat. And I am delighted today to be interviewing, start with Cara Delia, who is a tech lead of TAG Environmental Strategy in the CNCF.
I forgot to mention that what we're doing here today, right? We're talking about environment and strategy, sustainability.
Yeah.
When it talks about because one of the big problems with big data centers, right, is that we have all this, we have all this hardware running. So what can we do about that? So sorry to interrupt there, but Cara, please go ahead.
Yeah, no worries. Thanks for having me. Cara Delia. I'm a part of Red Hat's OSPO. I work in the upstream in one of the communities I'm in is the CNCF, focused on environmental sustainability. I'm the technical lead for the TAG or technical advisory group. And I'm also the working group comms co-chair. Huamin, over to you.
Thank you, Cara. Also, nice to meet you all. My name is Huamin Chen. I also work as Red Hat. I joined Red Hat about 10 years ago. Actually, this is coming my 10th year's anniversary. So I also started working on the Kubernetes ever since this was started, and also joined the CNCF ever since then. So I participated in a number of CNCF hosted projects, and most recently we created KEPLER, which is for the sake of environmental sustainability, to provide the tool chain for people to understand what their energy consumption is. And that project is developed by major contributors, including Marcelo, who is sitting next to me this morning.
My time? Probably yes. So hello, I'm Marcelo Amaral. I'm from IBM Research in Tokyo. I'm located in Tokyo. I've been working with Kubernetes maybe almost since the beginning too, with different projects, doing different things. And most recently, actually for the last couple of years, I've been joining efforts with Huamin and with Red Hat to develop the KEPLER project to improve the power models and the performance and scalability of the KEPLER itself, and try also to investigate and publish papers and blog posts about the KEPLER.
Cool. So to kind of get started is so what is the point of kind of thinking about a tag group around this subject? So any of the three of you can answer, but what is the the charter or the goal, and why is it considered a problem?
I can hop in. So the tag is obviously leveraging open source community to define the environmental sustainability factors. So through the UN, there are 17 Sustainable Development Goals, or SDGs. And the tag is focused on the cloud native landscape to incubate and advocate for open source projects to observe and measure the cloud native infrastructure and to combat environmental challenges. And so it really is around raising awareness on environmental sustainability, and the key element of that is through open source.
Okay, and what about open source, why? Like what about open source makes that more achievable or a better goal?
Well, they're goals that everyone needs to comply to, whether regardless of industry, and every industry has a data center, and so it's leveraging instead of recreating the wheel, it's being able to use the principles of transparency and obviously collaboration to create those standards. Because really, so the SDGs came about through the Paris Climate Accords in 2015, and even farther back than that, but reaching the net zero and goals for 2030 and for 2050 came about. And so by collaborating, you're not reinventing the wheel, you're all on the same page, and you're able to integrate environmental sustainability reviews into your release cycles. And ideally, those are going to help impact your carbon footprint in a positive way.
So what does this have to do with Kubernetes?
Well, this has to, well, and I don't want to be taken over. Why don't you jump in here?
Yeah, I think Kubernetes as its by status quo in a data center, cloud native data center, has become the infrastructure for the people of choice. People who are using the modern technologies, microservices in particular. So this becomes one of the biggest infrastructures in the world. Anything that can help the Kubernetes cloud native environments to achieve the sustainability goal will be very beneficial to the whole computation environments and the whole industry. So we believe that is the great open source environment we should be operated on, and also one of the most impactful projects we can help. So that's why we started in Kubernetes cloud native ecosystem.
Gotcha. I would kind of ask too, like, Cara, I think you kind of explained why kind of open source feels like the right answer for you. Huamin, can you tell us kind of what brought you to open source in the first place, or what brought you to Kubernetes? Kind of beyond this particular scenario.
So, I mean, open source actually provides different perspectives. When software engineers developing software, they have the choice of whether does keep it private or open. Being open gives you advantages such as, people can jump into a project without having to be pre-assigned, and anybody who has particular interest can look at your projects, give you advice, and even make contributions. That's opened up a huge host of opportunities over there. Second of all, especially in the environmental sustainability, we need to have transparency, open standards, and open technology. Without this, any of the closed-sourced technologies and methodologies will be received with a doubtful slot. So we believe open source, especially in sustainability, makes a lot of sense, and will accelerate the innovation in this space. So we believe this is the way we are doing the right thing. And also, Marcelo, as a research perspective, you probably can see open source as a different, bring different values. Would you mind just explain from your perspective?
Yeah, well, maybe I will start with why Kubernetes. So I think, Kubernetes won the battle for the resource manager, the cluster resource manager that we have seen in the past. There was like, OpenStack, Mesos, Kubernetes, a lot of things. And Kubernetes become like the most, used cluster resource manager framework that is being deployed, and right now everyone is using that. So all the public clouds and private clouds, people are using Kubernetes, unless they have like something very, very, very specific. I think people are based on the cloud-based workloads are totally deployed in Kubernetes. The majority of them, I would say. And given that, the Kubernetes community, Kubernetes is also open source. So it's also drives, all the directions for empowers other open source projects. So, and then we have also this, the CNCF, that is, effort to, consolidate all the open source community together and inside the Kubernetes ecosystem, which makes it easier for people to find projects and also contribute to them. And I would say that all of these projects, all the Kubernetes communities, can benefit from sustainability. So sustainability can bring benefits for reduce the energy costs, for example, in this perspective, and also for, um, uh, minimize the climate impact. So, for sense of awareness for the environment, things like that. And all the benefit for open source, I also see the other benefit is the collaboration between the community. I know that big companies can develop very good softwares, of course, but there is no way to compete when a lot of big companies are put effort to develop the softwares, isn't it? So we have collaborations. For example, the project that we are being working right now, isn't it, the KEPLER? Or we are going to talk later more about that, but just to say, we have a lot of companies involved in that: Red Hat, IBM, Intel, and other partners, which makes the discussion more broader. We have received more feedbacks and have more people to work on specific features that we can improve on the project.
Right. So environmental sustainability goals led to the development of the KEPLER project. Can you give us a little history for the KEPLER project?
Yeah. So the project, when we conceived the project, so we have actually a number of discussions, meetings, surveys. So we identified opportunities and the gaps in the current status, and then developed the projects from that basis. So in the very early, I think that's probably end of the 2021, we surveyed a number of existing projects, and we are looking at the cloud native infrastructure space, and we believe there's opportunities and urgencies for us to get a new technology that's applicable to lots of use cases. Just for your reference, the existing, by the time we are looking at the space, there exist practices. There's either estimates by a number of data sets or by some of the measurements on environmental environments. None of these methods can reconcile with each other, and none of these methods can be used universally in all the cloud native space, meaning that's environmental as well as virtualized environments in public clouds. And there's a number of other things architecturally, including how we are going to get the information that we need to estimate the energy without using a lot of resources, how to use the latest Linux technologies like eBPF to minimize our footprint. These facts can go a long way. So we come up with the idea of creating the KEPLER projects based on these surveys, learnings, and new technologies, and that becomes successful.
And
Yeah,
so
maybe,
what is,
yeah,
oh,
sure.
sorry, go ahead.
No, just add some more motivation here. Like maybe someone can ask, say, there are some tools in the public cloud that reports carbon footprint, isn't it? So like the CloudWatch in the AWS, IBM also has its own tool. However, it's changed the granularity. For example, the AWS and IBM at the public cloud. I'm not sure about the other ones. I need to check better. But I mean, the name of the tools that are doing that. But what is similar to all of them is the granularity. It's per month, so it's report the carbon footprint monthly. And this is hard to do optimizations, and although it brings some awareness for the user, it's hard to do optimization and understand what's the exactly part of the workload it's consuming more power, things like that. Also do some scheduling decisions where we are going to run things in a monthly granularity. And I would say that KEPLER brings here some different perspective that we can show the energy consumption in per seconds or per minutes. So it depends on the granularity that it's configurable. And this brings more opportunities for optimizations.
So in other words, kind of like the kind of existing tools are almost like too broad, or they're kind of too far away from the application itself to kind of know entirely what's going on. Is that kind of what you're getting at? Is like you can give kind of finer grained information that can be a little bit more like application aware, so that you can affect those workloads.
Mm-hmm.
Yeah. So what is KEPLER reporting exactly?
So we, at a high level, we can report the the server level, so the Kubernetes node level information about the energy consumptions, including CPU, DRAM, GPU, and we are going to support other data hardware types as well. And we also support at the container level. So if you are running a container in Kubernetes, we can help you to understand how much energy used by the containers as CPU, GPU, and DRAM, things like that. And we can, if you are running on virtualized environments, we can also report how much energy used by the VMs. And if you also run this as traditional OS environments using the database or some other specialized software, we can also report energy as a process level. So this will help you understand workload energy consumptions at different granularities. And tools based on KEPLER to aggregate this information to a different level across different nodes by namespace labeling or something like that can help you understand the energy consumption in a distributed environment that can open up even more opportunities. Because we are using models, actually, Marcelo is also a research scientist adding lots of model support because the models itself can be decoupled. We are using the models to predict, to estimate how much energy used. These models can also be used for other purposes as well. For example, if you are using the models in scheduling, you probably can using energy efficiency, bring energy efficiency into consideration when you're making the scheduling decisions. Similar things can go a long way. So scaling and tuning can also borrow a page from the tuning, borrow a page from the modeling. That will help them to understand if we are turning the knob in this way, what's the energy consumption will look like. And that will open up opportunities for innovations in optimization of energy consumption.
So you kind of alluded to it just now with the question I was kind of thinking about, which is you were kind of saying that, you're using models, right? With everything in the environment being virtualized, how do you know what the actual energy consumption is? Or is it that you're making, an estimate based on, a guess about what kind of the hardware is underneath? Or, are you actually receiving that? Like what is it you're basing it on? Or is it kind of the other end of the spectrum where it's kind of like, you're using more than you were before rather than necessarily kind of like a hard number?
Yeah, so Langdon, you actually, Marcelo, go ahead first.
Yeah, so there is no simple answer for that. Maybe we need to do some background introduction for what's the power. Why do we need a power model? Isn't it? So we have two contexts that we were saying. So the bare metal that we have access to the hardware, and the virtualization where typically the hardware is not exposed inside the VM. Isn't it? So especially in the public cloud for security reasons. So let's focus on the first example in the bare metal. There is no hardware counters to count the energy consumption of applications. So then we still need to use power models right here. So we have the energy consumption of the CPU or of the entire node energy consumption. And then we need to split this energy consumption to the process that are running on the node. And the basic assumption is, for example, let's think about the CPU. If a process is using 10% of the CPU, 10% of the energy consumption of the CPU, it's related to this process. So defining the CPU utilizations can be more tricky because CPU can also have instructions, cache, a lot of things. So maybe we might need more, metrics to define utilization if we want to more finer, more occurrence for to split the energy consumption. But basically, in a broader view, we can use, for example, CPU time and get those ratio and divide the power. This is when we have access to the directly the power consumption from the hardware. So for example, then we know that 10%, we just take 10% of the CPU utilization. However, on virtual machines, we don't have access to the energy right now. We don't have access to the energy consumption of the node. We envision maybe in the future, cloud providers maybe provide some API or things for that will be perfect, and KEPLER can access that, the energy consumption of the VM and split this internally. But right now, we need to do predictions. So prediction is basically a regression. We collect we on a bare metal node, we ran a set of experiments with many different workloads in change the CPU frequency, change how the workload will behave in the bare metal, collect all this metric, and just plot some regression model based on this metric. This is the power model, basically simple as that. So the power model, of course, it has limitations. We can maybe discuss in the future, later, what's the limitation for that. But this is the power model, and the power model based on the regressions, based on some specific metric, for example, CPU time, we can use this power model on virtual environments to estimate the energy consumption for a given CPU utilization that it's inside the virtual machine.
Gotcha. So yeah, so basically you're making kind of projections about what's going on based on the kind of the information you have, right? Which,
Yeah.
And it's interesting. I would imagine that there is, kind of a relatively high issue with, kind of where it's running, right? I mean, you probably have a pretty good advantage when you're running in a well-known data center, right? So if it's my data center, right, I can probably kind of inform, hey, these are the types of CPUs we're running, that kind of thing, and I can probably give better data. But that's what I was kind of wondering is it's a difficult thing to monitor because it's not a normal API that we normally give in an application.
Yeah, I mean, I guess my big question is, what about public cloud? Do the public cloud providers actually provide accurate energy data?
Yeah,
I think we have to.
It's a request, isn't it? So I think
actually, we all have
the
an
end users,
answer for that.
I think the end user. Sorry, yeah, go on. Oh
no, go ahead.
Marcelo, you can
Yeah,
start
we'll go to each in turn. Marcelo, why don't you go first?
I think if the end users, start to ask more about that to the cloud providers, it's changed, the priorities. Of course, I have the opinion that the cloud provider, they can provide that. We have this data. So, and it's just a matter of people are solving different problems, putting all the workforce to different things. So, however, if there is a big requirement from many clients, the cloud providers will provide that, as they provide the carbon footprint monthly, so they can just lower the granularity and provide this information maybe per minute or per hour. Per hour would be already very good for us.
Cara, what do you go to you next? Because you haven't had a lot.
Yeah, well, so I think the key question is accurate, Josh, and that is so AWS and Azure and GCP or Google Cloud Provider, they have CO2 dashboards, but they're at the cloud service level, and they're not having that granularity at that pod level, which KEPLER provides. But also the other piece is that they're really is not, or there isn't a industry standard. And so that's another reason why it's important for open source. So there's not an industry standard around energy consumption and how to report it, or carbon footprint for containers. And so the real opportunity is, open source, open standards for hybrid cloud, and how you report that as far as the E and ESG.
So I also imagine the models aren't particularly standard either, right? So that's so it's you kind of have both sides of the problem. It's not only like how do I go get the information, but then what's a legitimate projection about that information as well. Huamin, did you want to add something?
Yeah. So as Cara just said, the standards is not there, and so each of the clouds can do its own thing and in its own way. So if you operate between multiple clouds, you get confusions. So that's thing number one. As we are providing these open source architectures, as Marcelo just discussed, there's nothing significantly harder for the cloud providers to adopt, right? Train the models, get the environments, and set it up, provide the models to end users. This can be done by everybody who are using the same methodology, and then that will be transparent and also adopted by all the end users, so they will understand what the metrics means by the cloud providers. So by providing fine granularity and also high resolution data, will help us to do a lot of good things. Not like monthly we receive a bill and then we decide what's to be done in the next month. We can actually do the real-time tunings, scalings, because that's the promise of the microservices. You can be very agile, you can be adaptive, and you can use in the adaptation to save energy. So the tooling is all, we create the tooling and the methodology and also the open source models. This can be adopted by the public clouds, and they can use in the similar methodologies to help us to achieve better goals. And also, public clouds can also help us to open up more APIs and insights into how they are measuring their sustainability. So, for example, as Amazon, each year Amazon will announce a new generations of their own private ARM architectures. They will also provide this generation over generation sustainability improvements, 30%, 60%, depends how you say which generation. But we never have a chance outside of Amazon to measure their, the power consumption. So it's really hard to end users to get any sense, how can I optimize my workloads using different architectures? That will save the energy consumption. So not disclosing this information or not disclosing this API will make it harder for any users to consume the products as well. So I advocate the open source way, and that's where we open up opportunities for not only for the end users, and also be beneficial for the cloud providers themselves.
I was actually going to ask kind of the wider question there, which, you brought up the Paris Accord earlier. Are there organizations within like the UN or other NGOs or whatever who can kind of give some of your kind of requests some more weight? Because there's a lot of, relatively prominent NGOs that are interested in kind of increasing sustainability and environmental awareness, or, are any of those kinds of groups involved? Do you see some of those organizations showing up? Is that something that we can, encourage or get more involved?
Yeah, so I mean, the Sustainable Development Goals are created by the UN, and right now, I would say that they are looking at this, but they are not giving recommendations. And primarily, the focus has been around sustainable finance, and so how the portfolios around or financial portfolios are with transitioning risk from kind of present day to their net zero goals, and or physical risk, whether if you're an insurance provider and you are going to provide coverage to a large corporation in Miami, Florida. But as far as actual creating the bodies and standards for data centers, that's really the other opportunity of there's other things that are happening in the LF Energy, OS Climate, the CNCF, Environmental Sustainability Tag, not just within the Kubernetes space.
Just clarification, LF is Linux Foundation.
Yes. Thank you.
Josh, did you have another question that you wanted to ask?
Well, yeah. So, but I mean, it sounds like right now the public clouds are not providing any of this information.
Or not in a way that is consumable by not their dashboard, right?
Yeah,
right.
Because, when Huamin was talking about moving workloads and stuff, I was, of course, thinking about public cloud, particularly because energy sources can differ a lot. Where, for example, on AWS, US East 1 is mostly powered by fossil fuel power plants, whereas US West 2 is mostly powered by hydroelectric power, which, if you're looking from an environmental perspective, would actually matter. But without that information coming from the public cloud provider, I don't know how to make use of it.
Yeah, that makes perfect sense. So we have a lot of thinkings about this distributed environments, how workloads can be relocated based on these delta differentials on the carbon intensity. That's something public clouds can help us to make such intelligent decisions by providing real-time, close to real-time metrics that we can use. So that will be very beneficial. So in addition to the carbon intensity, there are also water consumptions. Data center needs cooling, and cooling needs water. So water is not a free resource. It has a lot of environmental impacts. So that is also related to the energy they consume. So as using energy as one of the major sources, making decisions on how to schedule workloads, how to use which data center you use, and that will be a lot of savings for every one of us.
And it's provably possible. Sorry, I was just going to say, because we already are allowed to select data centers based on like data, right? So because basically the EU requires certain data to stay within the EU, et cetera, right? So like we have, they have the capability to give us some selection over that. Sorry, Cara, did you get to add?
Yeah, I was going to add to that is that there are the tools for measuring carbon footprint that are associated with the cloud usage, but really it's going back to the G part of ESG is that methodology, everyone's using different methodologies and how they are measuring that. And so the scope is going to look different. And so again, going back to a couple questions, the accuracy is not there. And so there are tools and there's ways to get disparate information, but not a holistic view.
Right. So to kind of change the conversation a little bit, so KEPLER is mostly about kind of sharing the information of what's going on, but I think Marcelo, I think you kind of alluded to like making choices based on what you kind of see in that dashboard, for lack of a better term. What in the infrastructure layer is being done, because obviously there's my app which I can kind of control and try to choose better consumption mechanisms for or whatever, but I can't really control how my overall infrastructure component runs, right? So like Kubernetes itself, or all of its little friends that I plug in. Are there efforts involved in trying to make those things consume less energy in and of themselves?
So maybe I can just so I think Marcelo has participates in a number of projects using virtualization, like a Kubernetes. So Kubernetes you think about the way that how the infrastructure is organized. So you have bare metal machines, and you stand up a number of pods, and then each of the pods will be solely responsible for its own clusters. And in Kubernetes, this is just one of the examples. So you can virtualize the environment. So each of the virtualized virtual servers could be responsible for its own clusters and own infrastructures. And you can fine-tune the sizing of the virtual cluster to be more resource efficient, and as a result to be more energy efficient. So that's one of those ways. The other way is to try to minimize the footprints of lots of other things in the infrastructure. For example, the control planes, right? Previously, we worked on a project called microchips. Microchips is basically a minimized control plane of OpenShips. That's where combine all the binaries, all the containers inside of the single binary. So you have the Kubernetes controller, is SAD API server, things like that, and Kubernetes in certain ways. You can coalesce them into a single binary, and that single binary will be requiring much less footprints than all of them running separately. And that's yet another project and technologies, so to speak. You can virtualize the control plane itself by running them inside of containers. So that is hosted control plane. As there are lots of companies doing this, including Red Hat. So you can scale it in and out of your control planes, and you can even hibernate them if you don't use clusters at all. So that's where reduce significantly the amount of dedicated resources in order to run your Kubernetes infrastructure.
Gotcha. Yeah, that makes a lot of sense. And are you seeing kind of a lot of take up? Is there a lot of people who find this to be a concern, or is that something that it's like the awareness? You're still trying to spread the awareness of tools like KEPLER and and the fact that this matters, or do you think that everyone who hears about it is kind of instantly like, oh yeah, no, that makes a lot of sense?
Yeah, definitely. Getting more visibilities will help us to accelerate the adoption. And also, we want to get people's awareness in both the usability of KEPLER and scientific methodologies that we are using. That's why this is a combination of development and research community with the end user together to co-engineer everything that's in this technology space. We will let people know how to use KEPLER by providing the best usability possible, and we will optimize the installation process, the observability, usabilities, and that's one of these things we can improve how the KEPLER can be adopted. And also, Marcelo, as the leading researchers in the community, and he has published research papers explaining how KEPLER is working and what's the scientific methods used by KEPLER itself. And then finally, we are coming to programs like KBE to raise the visibilities. So hopefully people can understand what the project is for and how can they use these projects for helping.
And also
if I may, yeah.
Oh, go ahead,
No,
Marcelo.
go ahead.
No, you go ahead. You have, yeah.
Just to add something, I think like increasing the visibility, showing developers, to increase their awareness of sustainability, energy consumption, is something very important. But in the end of the day, things that makes more impact, it's like government requests. So for example, it's been, I think, last year, the European Union requests companies to report the energy consumption of AI workloads in Europe. So, and this changed the market a lot. Even the KEPLER become much more important, in the community, because this is not a hard request, but it's just a soft request, as far as I know. We should double check that. But with the movement of governments to request that, it's may make the companies to move towards the awareness of the energy consumption and the carbon footprint. So, and I envision that in the future, those kind of requests will be much more often. So, and it will become much more important, standardize everything, as Carol was saying. Standardize between companies is something that it's challenging right now. For the audience that doesn't know what does it mean, it means, for example, maybe AWS is reporting the network energy consumption, but the other cloud providers are not reporting that. Then it's hard to compare things. What's being put in the equation? So companies are using different equations, and it's hard to compare things. Data centers, also the carbon footprint. Some data centers use solar panels, and this is not easy to know. It's internal. So, and we have no, actually, there are some tools that shows some carbon emissions of data centers, but we don't know how much solar panels they are using. Only the cloud providers know that. So there are some gaps that is still there. But again, when governments start to push more to this direction, I think things are going to move faster.
Yeah, and dovetailing onto that, that's a perfect segue. So what I was going to share is that from that macro level, from an industry perspective, telecommunications or telco uses 2 to 3% of the world's energy from their data centers. And so as far as standards that are coming forth primarily from the EU, as Marcelo had mentioned. So Europe, some in North America and in APAC or in Asia, there is more interest, but it does have to come kind of from the trickle down, like from the top down. Certainly, we want to make sure that developers can feel empowered and that they are partaking and contributing to KEPLER, the other projects within the tag or the CNCF tag, and then Linux Foundation Energy and just other sustainability projects. So I don't think it has to all be top down, but where the real impact is going to be seen is, like Marcelo was saying, is in government and is going to be through regulation and then the big industries.
And from the KEPLER community, we want to be prepared for this time, to have the perfect tool for that.
Exactly.
So to veer off into the technical here a little bit, how does KEPLER collect its data? I mean, where's the data actually coming from, and how does it get analyzed?
Yeah, so we collect data as different layers. As the OS layer, and we collect data from CPU instruction cycles. These are the 4 performance counters, usually are available on all of CPUs. And these are generic hardware counters, and associated with the software counters from the context switch. And most recently, Marcelo added something about the page cache and things like that. This information we collected from OS layer. We are bubbled up to the user space layer, where we collect the energy data from different counters. The Intel has its REPL, runtime average power level counters we can read from CPU. ARM has its own, depends on the vendors, has its own methods of reporting it. And also, certain things like power meters, and that's come from ACPI, can also report power consumption as the whole system, including the also like technology like Redfish can report power consumed by the server at the control board level. So this power information, this utilization by process level information will be fed into the power models that we just discussed to attribute the energy as different aggregation levels, process, container, VM, and pod, Kubernetes pod. And then this information is exported to Prometheus, so people can view on their dashboards once they collect the Prometheus metrics, and that will help them to understand how power is being used at different levels.
Okay, of course, I have to ask, how much overhead do the collectors introduce themselves?
We are trying very hard on it.
Yeah.
So we started off as let's just say a couple of years ago when we imagined how much energy, how much CPU utilization footprints KEPLER uses in both the eBPF level and user space level. At the time, we found out it's below 2%. We thought that was the state of art, but it turns out on certain environments like the real-time kernels, KEPLER actually uses much more. So we take a lot of optimizations, so reduce a lot of things. Marcelo also made a big contributions, removing a lot of redundant code and providing the profiling mechanisms, so we can pinpoint exactly where optimization can be done to reduce the footprint. So we are very proud to announce that KEPLER is using a very low overhead in terms of the CPU utilization, sometimes below 1%, sometimes below 2%, depending on the environment and different configurations. We believe this further improvements can be done and by using even more optimizations. But we are, this is no ending. There's no ending. We are trying very hard to make sure that KEPLER is very friendly and consuming very low footprints in order to give you the numbers you need.
It's always the trade-off, right? I was gonna ask kind of, and now go kind of the opposite end of the spectrum, is like going back to the tag itself. What is the goal? Like what is it that you're hoping that you're going to really be able to accomplish, or how do we, or how do we invite more people to that conversation, and how do we, how can people get involved? I was going to share the link to the site in a second, but like that's just a web page, like what is it you're hoping to get people to do?
Well, the biggest thing is come to meetings, and but the biggest thing within the tag, so we formed about a year and a half ago, and we're accepted, our charter was accepted into the CNCF, and we have been a small grassroots team. And as time has gone on, and especially with all the work that's being done within Cloud Native Sustainability, we have a Cloud Native Sustainability Week event we just started our first last year, so I shouldn't say every year. And we just need all hands on deck in any region. We just open up the tag to Asia Pac, and we want to make sure that everyone feels like that they can contribute. And contributing can happen through non-coding and coding ways. So we have a green reviews working group that is focused on developing green best practices into your software review cycles. But then there's also an extremely large arm, which is the working group comms. So that's, managing our website, getting the word out in region, social media. I mean, just so much. And the other piece is connecting to other sustainability focused organizations. So one of them being the Green Software Foundation, also within the Linux Foundation purview. And then making sure that there's cross collaboration, because again, we really do not have time on our side, and that's why all hands on deck. And but truly just first coming to a meeting and seeing where you're interested in, and there is no short of work to be done.
So I was gonna, and I should have asked this while we were still talking about the kind of more technical questions, but one of the things we do like to ask, right, is like, in the next, 3 months, 6 months, some reasonable time frame, what are each of you most excited about for what's going to ship in KEPLER or the tag itself? That you're looks like we just lost Cara, that you're most excited about showing up.
Oh, she's back.
Huamin, why don't we start with you? And
okay.
I'll repeat the question for you when we get to you, Cara.
So we are going to be very excited for the new offerings from KEPLER. Obviously, the better accuracy, better supportabilities, and better usabilities. Specifically, we come from a traditional data centers view and how we can measure the cloud usage in the data center cloud environment and the generic microservice type of view. And we also expand that into different environments, including the bare metal, OpenStack kind of environments, and also the traditional OS environments. And we also plan to support the more diversified GPU environments. So if you are using GPU in certain other ways, we most likely in the large language model, this GPT era, so you're going to have a lot of optimizations in GPU, and we're going to support the different GPU configurations, things like that. Right.
How about you, Marcelo?
Yeah, I want to add about the GPU part. So we support GPU power consumption. However, there is a new trend for virtualized GPUs that it's called like MIG feature. So it's hard-coded partitions that, for example, NVIDIA GPUs, I'm just saying that, the example for that, it can partition the GPUs with predefined size. It's not flexible, but it's possible to partition the GPU. I think this might be more common in the public cloud in the future, to have like actually have slice of GPUs instead of the whole GPU, and just change the power model. Okay, because right now we need to also have the same problem, like to try to associate the power consumption to partitions and then to processes. So it still needs some investigation. So I think for the next months, it's something that will be the feature of KEPLER. We're investigating that. I would say, as we were saying, we are always trying to minimize the overhead. The overhead, it's relatively low, but we are always trying to minimize that. So optimizations, we are always doing that in the KEPLER.
Gotcha.
And the last thing is we want to something that I don't know if we mentioned very, very well that, but power models are specific to the hardware. So different hardwares consume different way the energy consumption. The energy consumption is different. So we have power models for different CPU models, and in the public cloud there are a lot of kinds of CPU. So we need to train power models for that, and we also envision for the future to train more power models, ask the community to contribute also. If someone has a different CPU, so train the power model, contribute for, making the power model public, and help people to, to have access to different power models. And we also envision for that, create more power models and have a bigger community also to contribute for that.
So Cara, just to reiterate the question for you in case you missed it, but the question was basically, what are you most excited to see in the next 6 months or so that's going to come out of the tag or come out of KEPLER, or but we are almost out of time. So one really strong answer.
Refinement. So I would say refinement around the work that we're already doing and having a clearer direction from the tag's perspective as to what we want to focus on as far as achieving those standards for reporting.
Gotcha. That was a very tight answer. I appreciate it.
Can I ask a technical question here? Because there's like development going on elsewhere, which is one of the things I've been wondering is so Kubernetes has been really expanding the capabilities of the pluggable scheduler. So is anybody actually working on tying the scheduler modules in with the KEPLER data so that I can actually say, hey, I want to schedule pods based on, 60% minimizing power consumption, 40% performance?
Yeah, I think that is the use case is being developed and the technology is coming along. So we have separate projects in the KEPLER community called PICS, Power Efficiency Well Scheduler, Kubernetes Scheduler. That is towards that direction. So we are considering the power models using the predictions, how much energy is going to be used if you are scheduling workloads in this way on different nodes, but their characteristics. So this is something we feel can generate a lot of optimization potentials from the community. So we hopefully can get more contributors and evaluators to help us to improve this project and make our environments more sustainable.
Well, on that note, that was a great tie-off, I thought. But thank you so much for coming. We really appreciate your time. We really appreciate your work, and I really hope that this show and all the other marketing efforts that you might be making are going to bring more people to the party and really help the community grow.
Yeah.
But I'm really excited to see it. So thank you. Josh?
What's the best place for people to show up if they're showing up for the first time?
I sent a link to the sustainability tag, and which has data about how to go to the meetings. So I think Cara was saying earlier that the best way to start is come to a meeting, and the work will fall out of the meeting and be very obvious as you get involved in the community.
Mm-hmm. We also have
absolutely. You can see the CNCF calendar. We actually have a meeting tomorrow, the 31st of January.
Mm-hmm.
Cool. Marcelo?
Oh, we also have community meetings for KEPLER. So if someone is interested specifically in KEPLER also, please join. We also have Slack channels, so ping us and we can discuss things.
Gotcha. Cool. And on that note, let's conclude the episode. And again, thank you for coming. Really appreciate your time.
It's a pleasure.
Thanks, everyone.
Thank you very much. Bye-bye.